Hello, we are the Big Bad Chemists. Today's topic will be about stoichiometry. This is a section of chemistry that involves using relationships between reactants and/or products in a chemical reaction to determine desired quantitative data. Under stoichiometry are four subtopics, namely atomic mass, the mole concept, molar mass, and percentage composition. But today, we will solely focus on molar mass. Avogadro's number is fundamental to understanding both the makeup of molecules and their interactions and combinations. For example, since one atom of oxygen will combine with two atoms of hydrogen to create one molecule of water, 1 mole of oxygen will combine with 2 moles of hydrogen to make 1 mole of H2O. Another property of Avogadro's number is that the mass of 1 mole of a substance is equal to that substance's molecular weight. For example, the mean molecular weight of water is 18.15 atomic mass units. So, 1 mole of water weighs 18.15 grams. To make that less confusing, here is a diagram for you to see the relationships between particles, moles, and mass. Scientists use the dimensional analysis to convert between the mass, number of moles, and number of atoms very easily. Dimensional analysis is basically all about conversion. We already know the one-step process or the basic mole to mass or mole to atoms process. But what if we were to apply the two-step process such that we will convert mass to atoms or atoms to mass? But for this video, we will be solving atoms to mass only. So let's begin. Our first example. How many grams are present in a sample of 3.7 times 10 raised to the power of 24 atoms of sodium? Let's put first our given, which is 3.7 times 10 raised to the power of 24 atoms of sodium. Then we divide it to the Avogadro's number, and 6.22 times 10 raised to the power of 23 atoms of sodium can be found in 1 mole of sodium. So we can now cancel the unit atoms, and what we're left are mole of sodium. And then we multiply it to the molar mass, and the molar mass of sodium is 23 grams. So the final answer is 141.32 grams of sodium. Our next example. What is the mass in grams of a sample containing 4.8 times 10 raised to the power of 23 atoms of chromium? Let's put our given first again, which is 4.8 times 10 raised to the power of 23 atoms of chromium. We divide it to the Avogadro's number, 6.22 times 10 raised to the power of 23 atoms of chromium. We'll now cancel the unit atoms, and what we're left are moles of chromium. Then, the moles of chromium, we multiply it to the molar mass, and the molar mass of chromium is 52 grams. And in 1 mole of chromium, we can find 52 grams of chromium. So then we can cancel the unit mole, and what we're left is grams of chromium. So the final answer is 41.45 grams of chromium. And that ends our video. Hope you learned something today. We are the Big Bad Chemists. Thank you for watching.